Okay, y'all, this is going to be our last lesson on quadratics for this chapter. So let's just review a few things. Here's the quadratic formula. It's how we can solve any quadratic, even ones that can't be factored. This formula has a bit inside of it called the discriminant. This b squared minus 4ac right here is called the discriminant. It tells us a few things. If b squared minus 4ac is positive, then you have two solutions. If it's negative, you have no solutions. And if it equals 0 exactly, you have exactly one solution. So that means you have crossing the x-axis twice, crossing the x-axis exactly once, or crossing the x-axis never. So far, all we've done with the quadratic formula is simplify. Today, we're going to actually calculate. So grab a calculator and follow along, please. Here, the a value is the a value is 3. The b value is negative 6. The c value is negative 8. If I run b squared minus 4ac, that becomes 36 minus 4 times 3 times negative 8. And I'm just going to type that into my calculator right there. 36 minus 4 times 3 times negative 8. Your calculator probably doesn't look like this, and that's fine. Just find a calculator to do this on. You probably don't want that calculator to be a phone or an iPad, but I get that it might have to be because, that's how the world is. So you'll note I don't do negative 6 squared. I'm just going to type in 6 squared. Even though b is negative 6, if you type in negative 6 squared, the calculator is going to tell you negative 36. And it's not negative 36. Negative 6 squared is positive 36. If you're going to type in negative 6 and squared, it has to be like this, in parentheses. That will get you the positive 36. So what I do is I just ignore the negative, and I just do 6 squared. So there's b squared minus 4 times the a value was 3, and the c value is negative 8. That is my discriminant, 132. So I now know that by the quadratic formula, my solution is going to be 6 plus or minus the square root of 132 over 2 times a, which is 6. Now I need to actually calculate this. I'm going to find the actual decimal solutions, and the decimals are going to be rounded because I'm going to run a square root. So we can calculate this. I do it in a few steps. First I do 6 plus the square root of 132. Then I press enter. Then I divide that by 6. So one of my solutions is 2.9. I'll call it 2.91. Then I do the other one. 6 minus the square root of 132. I press enter. I calculate that first, then divide by 6 again. The other answer is negative 0.914. These are my solutions. About 2.91 and negative 0.91. The order in which you calculate this is really important. Suppose I did this. 6 minus the square root of 132 divided by 6. Well, this isn't going to work for two reasons. One of them is, in my calculator, this square root has to be closed. It has to have a parenthesis to close off and just mean I'm just square rooting 132. But if I press enter right now, the calculator is going to do things in this order. The first thing it'll do is the square root of 132. It's going to calculate the square root of 132 first. The second thing it'll do is divide by 6. Then the last thing it'll do is 6 minus whatever that answer was. So I get something totally different and totally wrong. So the order of operations of the calculator matters. You want to calculate the top first, and then as a last step, divide by 6. So I've got a couple more here that I'll do real quick just to kind of show how this can work. The quadratic formula only works if you're equal to 0. So make it equal 0. Subtract 6 from both sides. Now, my a value is 2, my b value is 5, my c value is negative 7. I'm going to calculate b squared minus 4ac, which is 25 minus 4 times 2 times negative 7. That's going to be 25 plus 56, so that's 81. I'll do it in my calculator to make sure, but I always like to try to do things in my head first to see how close I am and kind of get better at my math. So if I do b squared, just 25 minus 4 times 2 times negative 7, 81. Sweet. Okay, so I'm going to run the quadratic formula. So x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Well, 81 is a perfect square, so I don't really need a calculator for this. You can if you want, but I now know that I have a 9. The square root of 89 is 4. The square root of 81 is 9. Sorry, I saw those numbers and said it wrong. The square root of 81 is 9. So I can do negative 5 plus 9 and negative 5 minus 9. And divide those by 4. So I get 4 divided by 4, which is 1, and negative 14 divided by 4, which is negative 7 over 2. And look, I didn't even need a calculator. Just, run the math. Okay, one more. A is 1, B is 2, C is 3. So I'm going to have b squared minus 4ac is 4 minus 4 times 1 times 3. I don't need a calculator for this either. This is 4 minus 12, which gets me a negative 8. Well, this means I have no solutions. My discriminant came out negative. Since it came out negative, I'm not going to go any further. I'm not going to bother with the square rooting or anything else because I know there's no solutions. So doing the discriminant first is still always a good idea, always. The worst thing it does is just nothing. The best thing it does is save you a lot of time. Let's talk about part of why we learn square roots. Gravity acts like a parabola. Okay, like when you throw a ball, I think you have an understanding it doesn't follow a circular path. It follows a parabolic path. It goes up fast, slows down, goes down slow, goes down fast. We're going to use this equation here to model the height of a ball thrown in the air. See, gravity pulls objects down to the earth at 16 feet per second squared. So every second, the ball is falling 16 feet faster. It actually might be 32. It is 32. This number, negative 16, is correct, but it's 32 feet per second squared. So this equation, we can plug in x for time. X stands for time in seconds. We can get out y as height in feet. Okay? So we plug in time, we get out height, and we can find the height of the ball over time. This is a quadratic, and I'm going to graph it just like every other quadratic. I'm going to start by finding the axis of symmetry. Well, the AOS is negative b over 2a, which is negative 20 over 2 times negative 16, which is negative 20 over 30 over negative 32, which is going to be something pretty small. Negative 20 divided by negative 32 is 0.625. So here's what that tells me. I want 0.625 to be in the middle of my table. And then I'm going to pick numbers kind of small to plug in for x after that. Like I'll do 0, and I think I'll do 0.2 and 0.4 and 0.8 and 1. And that's probably too many. Let's just count by halves. So I'll do 0, I'll do half a second, I'll do 1 second, I'll do 1.5 seconds. And that's probably going to be enough. Okay, so let's just plug in a few numbers for x and see what we get out for y. So I'm going to plug in 0 for x. If I plug in 0 for x into this equation, it becomes 0 plus 0 plus 30. So the ball starts at the point 0, 30. I'm going to plug in 0.5 for x, and this requires a calculator for me. I could actually maybe do this without a calculator. In fact, yep, I actually can. It's going to come out pretty cleanly without a calculator, but I'll do it anyway with one. If I plug in 0.5 for x, it's negative 16 times 0.5 squared plus 20 times 0.5 plus 30. This is at 36 feet. Let's plug in 6.25. 6.25 is going to be the vertex. Okay, sorry, 0.625. If I do negative 16 times 0.625 squared plus 20 times 0.625 plus 30, I get 36.25. So at half a second and 0.625 seconds, they're really close to each other, which makes sense. So the ball, its highest point is 36.25 feet. Okay, this is all in feet, so that's the highest point it reaches. Let's plug in 1. Plugging in 1 is pretty simple. It's just negative 16 plus 20 plus 36. Which is 40. That doesn't make any sense. And that's not 36, it's just 30, so it's 34. Let's plug in 1.5. So I'm going to do negative 16. Negative 16 times 1.5 squared plus 20 times 1.5 plus 30. And we get 24. I'm going to need a few more points, I think, because I want to get down to where I hit the ground, right? So I'm going to plug in 2.0. Let's plug in 2 for x and see when do we hit the ground. And so you'll see this just takes like a lot of computations. It's going pretty slow for me on this machine because the computer has a tough time keeping up. But when you do it on yours, hopefully it can go faster. Oh, shoot. I did 20 squared. I'm going to do 20 times 2. There we go. This should be 6 feet. Okay. So I'm going to plot these points. I have to go as high as 30. So if I count by threes, so I'll go 3, 6, 9, 12, 15, 18, 21, 24, 27, 30, 33, 36. On my thing, if I count by threes, that's perfect. On my x's, I think I'll count by halves, quarters actually. So I'm going to call this a half, and I'll count by halves. So here's 1, 2, 3, 4, 5, 6. I think that's too big. What if I got to do it though. Do I? It's tough to decide what to count by to get things to best fit. I have to go from 0 to a little bit above 2. But if I count by quarters, then it's like, here's a half, here's 1, here's 1.5, here's 2, here's 2.5, here's 3. That's actually like perfect. So I'm counting by quarters. Yeah. Let's plot some points. We have the point 0, 30 right here. The ball starts 30 feet high. We have the point 0.5, 36, which is here. Then we have the vertex, which is like going to be right about here-ish. We have the point 1, 34, which is like here. We have the point 1.5, 24, which is here. And the point 2, 6. 2, 6 is like right here. So we know the ball is doing something like this. It's a very good picture of what's happening with the ball, where the x-axis is time and the y-axis is height. What I want to do, though, is figure out when does the ball hit the ground? What is this point right here? To find when the ball hits the ground, I'm going to run the quadratic formula with my equation, where my a value is negative 16, my b value is 20, and my c value is 30. So it becomes b squared minus 4ac, which is 20 squared minus 4 times negative 16 times 30. And that's something I'm definitely going to do in my calculator. (20 squared minus 4 times negative 16 times 30. So this comes out to 2,320. That's my discriminant. My discriminant is positive 2,320. So now I can do x equals negative b plus or minus the square root of 2320, all divided by 2 times a, and 2 times a is negative 32, because a is negative 16. So I'm going to run the quadratic formula. I get negative 20 plus the square root of 2320, and I calculate that, and divide that by negative 32. Okay, that came out to something negative. which doesn't make any sense. But the reason that happens is because the calculator, the equation, thinks we can go back in time also. We can't go back in time. So when you get a negative answer, understand it's not a problem. It just in this case doesn't make any sense. The other answer should come out positive. So that time I did 20 plus. This time we'll do negative 20 minus the square root of 2320. Get that. Divide that by negative 32. We're going to get a nice, pretty whole number. Well, not whole, but positive. It's 2.13, which is right about where this graph looked like it was. 2.13 seconds is when we hit the ground. So the highest point the ball reaches is 36 feet. That happens at 0.625 seconds. And at 2.13 seconds, the ball hits the ground. Okay, so we can use a quadratic formula. We can graph. We can find the height of a ball given time because gravity pulls things down in a parabolic form. Thanks for watching. That was a solid chapter.